Okay, so next one is rolling. What happens in rolling or in metal forming process of rolling? Rolling is nothing but it is one of the operation of metal forming. Okay, so in rolling operation, the material will be compressed in between two rotating rollers, such that the thickness of the strip will be reducing from one thickness to next thickness. That is from they'll call it here as H0 and H1. Okay, so there will be no pulling force or pushing force is applied, but the pressure of the friction at the interface of raw material and strip of the roller will be pulling. Okay, so to avoid the bending of strip, there will be bending of strip where the surface velocity of both the rollers must be equal, and that they will call it as V top and V bottom. Okay, so in V top, for V it is pi dn. Okay, so pi dn of top will be equal to pi dn of bottom, and cancel both the pi's. That therefore the final equation will be dt and t. That dt and t, that is d top and n top will be equal to d bottom and n bottom. Okay, so to ensure the stable equilibrium condition of the rolling operation, the surface between the roller and strip must be equal. Okay, the surface between the roller and strip must be equal at both the sides. Okay, in the bottom left corner you see where the from look at that diagram where the surface between the roller and strip must be equal, where the both the sides of the diagram of both the rollers also must be equal. So because these diameters are equal, the rpm will also be equal, so that the usage of the second gearbox will be avoided. Okay, and there are many assumptions made in analysis of rolling operation. So every metal which is undergoing the metal forming process is considered as incompressible only. So incompressible means material can be compressed, but volumetric changes in the material is assumed to be zero. Okay, that is called as incompressible. Where I'm telling you again, incompressible means a material can be compressed, but the volumetric change in the material is assumed to be zero. So volume before rolling will be equal to volume after rolling. So this is why this condition arises. Okay, many people will have doubt in this, how volume before rolling and will be equal to volume after rolling. So here we have made some assumption. In that assumption, we are considering the metal forming rolling metal forming operation to be incompressible. Incompressible can be compressed, but the volumetric change in the material is assumed to be zero. So width of the strip and the next point is width of the strip is assumed to be constant, where B naught will be equal to B1, that is equal to B. Okay, so during rolling, when compressive force is applied along the thickness direction, the material is getting compressing in the thickness direction, so that the volume of the material is reducing in thickness direction. So because the material is considered as incompressible, whatever the volume reduced in thickness direction has to be increased either in width direction or length direction or both. Okay, so because of the rollers are rotating, the roller is pushing out the material only in length direction, keeping the width of the strip remaining constant. From therefore again for this one, volume before will be equal to volume after. Here h naught b naught v naught will be equal to h1 b1 and v1, where here v1 will be greater than v naught again. So the zone present between entry and exit plane is called as deformation zone. To assume the strip, to ensure that the strip is pulled by the roller, the surface velocity of the roller must be greater than the strip velocity at the entry also. So here V will be the surface velocity and V naught will be the strip velocity. So on moving along the deformation zone, the strip velocity is continuously increasing, but the surface velocity of the roller will remain constant. Hence, at some point along the deformation zone, the strip velocity will become equal to the surface velocity of the zone. So beyond that point, if strip velocity is further increasing, hence at the exit of the hence exit of the strip velocity will become greater than the surface velocity of the roller also. So again, in the deformation zone, the type of stress induced are compressible and shear, whereas the compressive stress are responsible for change of shape of the component. They'll ask you which stress is responsible for change of shape of component. Change of shape of component, that is compressive stress. Okay, so compressive stress are responsible for changing the shape of the component, and compressive stresses induced in the material become equal to flow stress. Okay, so compressive stress becomes equal to flow stress, and at the exit and plastic deformation, the exit and the plastic deformation zone will be produced. Okay, this is the explanation regarding rolling. And next one, there's slip, the relation between slip and relative velocity. So the maximum percentage slip present in the lagging zone is called backward slip, and the maximum percentage slip present in the leading zone will be called as forward slip. So backward slip will be v minus v naught by v, and forward slip will be v1 minus v by v. So this is relation between slip and relative velocity. Slip is directly proportional to relative velocity too. The next relation is between pressure and slip. So pressure will be inversely proportional to slip. Okay, so at the entry, the pressure is minimum due to maximum slip along the deformation zone, where the pressure starts increasing due to reduction in slip and becomes maximum at the neutral point. So beyond the neutral point, the pressure once again starts reducing, and it becomes minimum at the exit. So the minimum pressure occurring at the entry and exit will not be equal. So based on this, along the deformation zone, pressure will be increasing first and then reducing. They'll ask you this. They might ask you this question also. So in the deformation zone, what is the relation of what happens to pressure? Either increasing, decreasing, or increasing and then decreasing, or decreasing and then increasing. So the answer will be it will increasing and then decreasing. So in the lagging zone, the pressure is only increasing, while in the leading zone, the pressure will always be reducing. Okay. Yeah. This thing is regarding pressure.